Hello, everyone. We are so excited to be speaking at the first ever Micro Frontend Summit. My name is Christine, and I'm the product specialist for portals here at Ionic.
Hello, my name is Josh Thomas. I'm the product manager of portals here at Ionic.
And today we're going to be talking about how to bring micro frontends to iOS and Android. All right, so to get started, let's just talk a little bit about what are micro frontends. Here's a quote from a thought leader in the space, Cam Jackson of ThoughtWorks. He says, "In short, micro frontends are all about slicing up big, scary things into smaller, more manageable pieces, and then being explicit about the dependencies between them." So take, for example, a chat widget. With a monolithic application, the chat widget would be built, updated, and deployed within the larger single code base with many other features. With a micro frontend approach, a development team would be dedicated to working on that chat widget, freeing up time and energy for other teams to be working on other features simultaneously. So this chat widget can then be deployed across multiple applications. Now let's talk about some advantages of micro frontends. So how does micro frontend architecture help improve app development? There are a number of advantages, but we'll be talking about the three most important advantages to the micro frontend architecture. So the first advantage is scaling and staying agile. So allowing organizations to scale their applications while staying agile. As a product increases in size over time, there's a constant battle to keep shipping updates. And as you add more developers, there's often more overhead involved. Micro frontends can help organizations continue to increase the number of developers working on one product without decreasing the speed to market. Micro frontends make development fast and efficient by enabling teams to work on their components in parallel as well, without affecting the work of other teams. And finally, micro frontends increases stability by making it easier to integrate new features and updates, since each component can be updated independently without impacting the rest of the application. Another great benefit is developer efficiency. So micro frontends improves developer efficiency, and efficiency is one of the key benefits of using micro frontends. Micro frontends lets teams manage and maintain their own code while maintaining a higher sense of ownership. So teams can focus on the most valuable code that they build for their customers. Micro frontends gives each team a chance to contribute their own strengths to the project as well. When organizations scale, they start to build teams that have a more specific focus. And as micro frontends are usually separated based on feature, each team can focus on their strengths. And finally, micro frontends ultimately reduce complexity among development teams because they allow teams to keep their overall mental model smaller, which makes it easier for teams to work on their own features in parallel and with their own timelines for releases. And finally, one other advantage of using micro frontends is to improve customer experience. Improving the customer experience may not seem like the most obvious benefit, but it's probably the most important. Micro frontend architecture gives organizations the opportunity to build customer trust. The faster you can deliver your value to your customers, the better the overall experience will be. And you know the value of your organizations, that your organizations provide your customers. And micro frontends lets that value come to them quickly through asynchronous building. And above all, the speed at which you give customers value ultimately means less friction, less downtime, and a better customer experience. So Josh, now that we understand the benefits of using micro frontend architecture to develop enterprise applications, let's talk about how these benefits are inherent to the web.
Thanks, Christine. So now that we've covered these advantages of micro frontends, why are they inherently web-based? Because when micro frontends are mentioned, usually they're in the context of web applications. What is it about web that makes it a great platform for micro frontends? The web allows for scalability, speed of delivery, and reduced complexity. It's a distributed, loosely coupled system. The web is defined by a set of specifications and standards on how content is created, and browsers should view that content. As long as you adhere to these, you can design a system that has pieces that operate independently, but can depend on each other. Web code is also evaluated at runtime. So the JavaScript application code is executed as source code, delivered as source code, because after it's delivered, it's compiled, interpreted, and then executed. This allows you to bring in code from other applications and execute them like they're part of the original application. And one of the most powerful features is that updates are immediate. Web code is downloaded at the time that it's needed, so there are no updates to your application required. The executed code is always on the latest version, as long as your caching is good. So this is a typical web-based micro frontend. We've got 4 applications here, or 4 MFEs that come together to create the application: a purchase flow, shopping cart, search bar, recommendation engine. And each of these applications has their own source code, their own build pipeline, their own testing, and their own deployment processes. But they all come together and they're experienced by the user in the same way. But this isn't a new idea, right? Like, frames have been around since 1996. But with today's JavaScript and build systems, the end result can keep UX, or user experience, front and center. So how do native teams make their applications more scalable, improve efficiency, and improve customer experiences? There are a few approaches that teams have implemented, and some are more common than others, and it can also differ across operating systems. The most common approach to improving scalability of native application development is breaking them into a module or plugin-based architecture. And this is for iOS and Android both. During development, each team can work on their own specific module. This allows teams to test and develop in isolation to a point. It does a lot to improve scaling, but there are a few things to think about with this approach. Some of the downsides might be that it requires discipline of the dev team to ensure the architecture can scale. Development teams have to use a separate dev app for testing and development versus what's actually created for production. And the shared functionality and the core functionality is difficult to maintain because it lives in that base application, not within the modules themselves. Overall, this could allow you to scale teams, but at the cost of your developers' efficiency. Now, for Android specifically, you can use a feature of app bundles called dynamic feature modules, which has the benefits of module development, but it comes with an improved delivery process. This uses advanced capabilities of app bundles, allowing certain features of your application to be delivered conditionally or downloaded on demand. So you can decrease the amount of code that's delivered to create something similar to a micro front end, but it's not actually independent code, and they can't be updated independently of the main application. Finally, you can also bring in web views, but we'll expand on this in a bit. For the important thing to understand, though, is that these are still monolithic native apps with a single code base. It's a monolith, but it's broken down into modules. It's a single release of code, and delivery of this can be delayed by App Store reviews as well. So abstracting these benefits in native can be difficult because native doesn't inherently do a great job of capturing all the benefits: speed of delivery, reduced complexity, and scalability. The amount of work that has to be done to combine at build time rather than runtime increases this complexity, as well as the review process and the code that's shipped as a single bundle does not improve the speed of delivery as well. So one way organizations try to bring micro frontends to native mobile is by using web in native. It seems obvious because micro frontends on web are much easier to do. So why not just take it and make it part of your native application? And there are some advantages to doing so. You get a clear separation between features that are developed, and they can be done so independently. You get an immediate deployment with web-based features because they're coming from a server. And the reuse of the web code can be done with your mobile app, your mobile site. And when I say mobile app, I mean both Android and iOS. But there are some disadvantages to using web views as well, and the benefits could come at a cost. And to be very clear, user experience is not something that you want to negatively impact for an improved developer experience of your current applications. So creating a seamless experience between native app and a web view is extremely important. For views to be effective as a supplemental experience to native apps, developers have added work. For example, logging into an app with a native layer and then jumping into a web view to see your profile, you've got to pass authentication information over to the web view to create that experience. And this kind of communication needs to be created by native developers. Allowing web views to interact with interactive experiences from native elements such as alerts, keyboard status bar, scroll regions, those are also things that need to be handled by native developers. In handling delegation of events for navigation, loading code, errors, permission requests, and general housekeeping that come with that are also something that need to be done by your native developers. And to truly make use of these micro frontends across multiple operating systems, you can develop it for iOS, but then you've got to look at Android and develop it there as well. And the biggest issue with web views is perception. They don't feel like they belong in the user experience. Requiring network requests to load web code creates a subpar experience when compared to the rest of the application. And Max says it best. The problem with the stock web views is that they just don't do enough and don't cover the surface area of what native developers typically need them to do. Knowing that web views can be used, though, as micro frontends, how can we use them and overcome these hurdles? And this is where Portals comes in.
Thank you, Josh. So yeah, let's go ahead and talk about how Portals can help native applications beyond what stock web views can do. But first, what are Portals? Or what is Portals? Portals is a plug-and-play solution that handles all of the messy and annoying parts of working with web views. And looking back at what we learned about the advantages of micro frontend and micro frontend architecture that we outlined earlier in the presentation, let's see how Portals can provide the same benefits for native mobile applications. So Portals is a scalability solution. Portals offers a scalable solution for native mobile apps. With Portals, teams can not only build and test new and updated features, but they can update these features autonomously and at their own pace, rather than waiting to bundle the app for deployment. Teams can then reuse these micro experiences across iOS and Android platforms. There's no need to build each feature separately. And because micro frontends are still built using web technologies, native teams can work on important native features, while the web teams can tackle the web-based features. That way, each team handles their own code bases and plays to their strengths. Portals is a developer efficiency tool. With managed access to native features, native teams can focus on their own features and gate access to the web teams to avoid stepping on each other's toes. Portals fully supports any stack with JavaScript compatibility, which makes building with Portals future-proof. And with access to a large library of core plugins and over 5 million web developers using and contributing to community plugins, developers will not have any problem finding exactly what they need to build the best mobile applications using Portals. And finally, Portals provides a better customer experience. So above all, customer experience is a top priority for enterprises looking to make the switch to a mobile micro frontend architecture. Because what's the point of doing all of this if the customer is gaining no benefit from it? Portals provides a better customer experience in a few different ways. With Portals, teams can automate caching and delivery of applications. In other words, any updates to the application are delivered automatically to the customer without needing to download a fully packaged update. Rather, when the customer opens the application, the app checks for any updates and delivers these updates to the customer automatically. With this automated caching and delivery benefit of Portals, features can be tested and rolled back instantly. And fixes can also be deployed instantly as well, which makes the overall experience to the customer seamless and bug-free. So I think we have a demo of Portals. Josh, can you share that demo with us?
Happily. Take a look. So here we're looking at an application that was built with Portals, and this is an iOS application. As we look at this, try to identify part of the application is done with web, part of the application is native. And this is a shopping app where you can go through, look at a product, get assistance for it. You could add a product to your shopping cart. I think we're going to select another product here, and why not select a mask? It seems relevant. We'll add that to our cart. And on the cart screen, you can see that we have a list of the products, and then we can also check out. So here we see my address, not actually my address. We can edit it, and then we could cancel or place our order. And then finally, we have a tab for profile where we see information with my avatar. And we can add a new address if we decide to. But I think it's important as we go through this to really get a better perspective on what pieces of it are native and what pieces of it are web. So we're going to use a tool called Inspect to allow us to highlight the web views. You might be surprised by this. We can see that the featured products, everything highlighted in blue right now is actually a web view and part of a larger native screen. And the Get Assistance page, the entire page itself is a web view. From the cart screen, everything on cart's native, but everything in checkout process is web. Even editing our address information. And this is in a sheet modal that you could cancel as well. And on the profile screen, everything under the profile tab is part of a web experience. This micro front end contains a little more experience than what a lot of the other applications have. But just to prove it, let's go ahead and inspect. So you can see here that this image is referenced through the HTML that's displayed within the web view. And this is done just so we can say we're not lying here. This truly is HTML. So let's see how we can integrate this into our iOS application. First thing we do is define our portal. In this case, we're going to drill into the featured application portal. So we add the portal view for it. We add it to the overall content view of the page. And then we set a few constraints on it so that it displays correctly. One of the things that we really need to think about here is the communication that occurs between web and native. So if I select that capacitor snapback hat and click on it, there's actually information that's being passed to native from web. So we're saying what item we've selected, and native listens for that event to take place and then segues to the screen that provides details about it. So we can create this decoupled experience, and that web itself, the web experience, is React. Here you can see the files from it. If we look at the React application, you see that the new featured component is really the only component that's in this experience, this micro front end. And if we look at that component specifically, we can see that it's just a functional component. You see we have must-haves, bestsellers, and there's the product itself. And when we click on the product card, it's communicating back to native and saying the item that we've selected and giving it a product ID. So we can rely on this event system to provide information from web to native if web expects the native team to care about it, and then the native team can make a decision on what to do with that information. This is something that you'll see in other micro front ends as well. So now we're going to go ahead and start up the web application. And you can see that development on this application can be done in isolation, and it can be tested in isolation. But it's kind of hard to tell that it's the same screen. So let's put it as a iPhone 12 Pro in Chrome. And then let's bring up the native application next to it just to show that it truly is so that it looks the same. And here you can tell it's exactly the same. So the development we've done on web is being displayed in this native application, and you can do the development on isolation. But what about updating? We're going to look at documentation for this. So we have a tool of updating called Live Updates from AppFlow, to where anytime a team makes a change to the web application, you can push updates dynamically on demand. So you don't have to wait for an App Store review process of the primary native application. You can update each one of the web applications independently. And here we're seeing how to add configuration of a live update to that micro frontend view in native. We're setting a channel, and we're saying that we're going to sync on add. What this does is allows all the teams who are developing the micro frontends to be used in the native application to do the development on their own. They get to decide when to do the updates. And this is why we truly say that Portals is a micro front-end solution for native applications. It's because you can't accomplish something like this without a tool that allows teams to contribute independently and on their own timelines. Appreciate your time. So did we have any questions come in?
Just a couple.
Wow. Yeah, we have more than a few questions coming in here. So fantastic session. That is so much to go over. So I think let's dive into it. First off, one question I had while I was listening into this was is this something like, are there any DIY alternatives to Portals or anything of this sorts? And why would you want to use Portals instead of those? Yes.
Sure. I mean, I kind of covered this in the web view section of the presentation. I think people are using a tool to allow them to accomplish themselves, but there isn't a tool that's really provided by an organization and backed. People are doing a lot of homebrew systems for it.
Mm-hmm.
There are actually quite a few organizations who have built these homebrew web views that have come to adopt Portals. Because having an organization focus on developing this and keeping it up to date with mobile operating systems going forward is really something that most teams want to depend on. They don't want to have to try to do this themselves and maintain it over the long term. But I think there's also benefits that Portals brings that you can't get with a normal web view. And a lot of that is the ability to update independently. Most web views, you're going to point to an outside web server and you're going to deal with network latency in order to show content. And it just doesn't feel right. And I think that with Portals, having the files on device and being able to update them independently is really a killer feature.
Yeah, if we all know that native has trained people to realize whenever there is any sense of a delay in loading anything, it becomes a less than experience, and people look at it pretty negatively. So having some way to reduce that latency is super important. So very, very good feature to highlight there.
It's an uncanny valley.
Oh, automatically. So we do have one question. Let's go ahead and prop this up. When describing advantages, you mentioned teams. Logically, it makes sense that micro front ends are great for large scale organizations with tens or hundreds of developers. Do you see the same advantages when you only have a team of like maybe 10 to 15 individuals? Or does it become a little bit too much overhead for the scale that they're operating at?
I would say mostly we see it adopted by large enterprise organizations who are trying to split up the work and scale a single application. I think that it can provide value to a team of that size, allows for that. Like if the team is split down into maybe 3 different teams with features that they specifically work on, I think it could provide value there. But I think in order to provide the value at a team of that small of size, the team has to feel the pain before they decide to embrace micro frontends.
That is a very good point. Should not be going just all gung-ho into micro frontends because of a hype. Should actually feel like you have a need for it.
Yeah, please don't.
What are the most common risks of converting a typical front end into a micro front end?
I think that it's more organizational risk than it is the risk of the application itself. I think that when you first adopt something like a micro front end and break down a monolith, there's quite a bit of work that's involved in that process. And I think you need to have a clear understanding of the structure of the organization and how teams are going to collaborate with each other in their individualized micro front ends to create the larger application. I think that you've got to do a lot of research and understanding of the organization before you really tackle that. And I don't want to say that there's not a technical limitation to it. I think that you need to understand shared dependencies across the micro front ends, identify who's responsible for those. But honestly, that all just feels like organizational challenges to me.
If only we didn't have a session that goes over some of the organizational concerns that you should have with micro front ends. Oh, wow. Look at that. Setting up the rest of our session so beautifully.
Not purposely.
Purposely. It just happened to work out that way.
Yeah.
Let's see. So here's a pretty interesting one. Can portals page receive data from native parts of the app? So I guess in general, I think we show this off. Can you send data from a native app to the portals?
We expect that.
Okay.
Absolutely. And one of the examples I gave during the presentation is talking about passing session data, like authentication information. And that's something that we know that people really want, and it's vital. So there's a way of passing data down to a portal to provide it before the first render occurs of the web view. And we call that initial context. And that's something where you would probably provide an auth token or a route or something like that. But we also have a way of passing data through events if data changes from the native application that you want the web application to respond to. So I think that there are a lot of different approaches we provide in order to solve that problem.
Awesome. Okay, well, let's just keep on going because we got a few more questions coming up over here. The chat has definitely not slowed down on them. And this one did make me chuckle a little bit. Most demos for micro front ends always tend to focus on e-commerce examples. Are there any other use cases where you could adopt a micro front ends approach to building your apps, or is e-commerce truly the only place that it would be benefited from?
No, we built the e-commerce example in the early days because it felt obvious to us about where the boundaries were across teams. And I think that's probably why people build it, is because it seems like an obvious solution that we all really easily grasp and understand. But I can't say that I have any customers of portals that are building e-commerce demos or applications at this point in time. It's all over the place what people are building micro front ends with and what they're trying to accomplish. But I think we just used e-commerce because it seemed obvious.
So no, you don't need to be building an e-commerce site. Micro front ends are applicable to every background.
Absolutely.
Here's a great question that is near and dear to my heart, and that is on security. What are some of the common security risks that people tend to overlook when dealing with micro front ends, and I think specifically with portals?
I think the biggest security concern for me would be bringing in micro front ends that your organization does not control. So outside code, outside scripts would be a concern. I think that with portals, we try to isolate that and create sandboxes so that each web view is truly a sandbox that doesn't have access to anything outside of it. So that's something we've tried to mitigate. But I think that a lot of the common security concerns, cross-site scripting, things like that are also concerns in micro front ends. I don't think anything about it changes that aspect.
So all kind of standard practice stuff. Nothing really changes. Nothing really changes when you are taking this approach. It's just you know what you know. Apply those principles.
Yes.
That's awesome. Cool. So hopefully that answered that
Might
question
be corrected
for you.
At a later session. So attend a later session to find out more information. But from my knowledge, no.
There we go. Attend other sessions here at the Micro Frontend Summit to learn more. At us, we have it all planned out.
I'm definitely not as much of an expert with web-based micro front ends as a lot of the other people we have speaking.
So here's a really good one that actually have a really what would happen if part of the micro front end breaks? Is there a fallback? I guess this goes without saying, probably with portals. How do you recover, or where is that recovery period?
I think that this is a case where I can't speak for that as web as much, but I can speak for that when building micro front ends in a native application that are web-based. And I think that's actually kind of advantageous, is that if it's web-based and you have a failure in that web-based micro front end, there's a way that the native application can listen to the portal to identify if an error occurred. And I think it's the responsibility of the web application to identify how to deal with specific errors as they come up. If it's a recoverable error, it's up to the web application on how to respond to that. If it's an unrecoverable error, that's something the native application can listen for and then make a decision on how to deal with that scenario. The real benefit, though, with portals is that if you've got an unrecoverable error happening in your web application, more than likely you have a bug. And maybe that bug's been reported on. It can be immediately fixed and an update can be published.
And hopefully that the way that you are working with the way that you're building that micro front end experience, you're going to be able to notice that bug before you even go ahead and deploy to the native app.
True. And hopefully your integration with the native app isn't going to expose something that you might have missed during your development process. It's easy to mock that out, what it feels like developing in the larger native application, because we have tooling that allows you to do that.
Awesome. Okay. Here's a really interesting one. Let's try this. What problems aren't solved by micro front ends?
That's a good question. Lots of problems. Most problems are not solved by micro front ends.
This is kind of a tease for, why don't you stick around for the next session, because we have a presenter who's going to be sharing all the things that micro front ends don't solve.
Yeah, I think there's things it doesn't solve. I think that it's actually a smaller set of problems that it does solve. It's a fairly focused solution. It's just that the solution is for organizations and for scaling of teams. So it's a solution that's gotten a lot of credit and a lot of visibility recently because it actually solves a real problem.
Yeah, it solves a real problem, but the harder, I think, the harder thing to realize if that's something that you need or not.
Agreed.
Okay, so we probably have time for a few more questions here, and I know a couple folks have posted the same question a few times. We have one person asking about the UI style and any updates that may happen along, say, Apple or Google update their design language. If we're working with micro front ends and having separate UI implementations across each of them, is there any concerns to be had when, for instance, Apple decides to update how headers look and behave? If our app does not behave exactly like that, is there any part where you could see those things not being approved or Apple coming down and throwing down the hammer?
No, I don't see any concerns with the approval process at all. I think that in our experience, a lot of organizations have their own design language and design system already, and they're not really relying on that's provided by Apple or Google out of the box. But if you do prefer to use the canned design language that's provided by Apple and Google, then maybe look at Ionic. The framework does an amazing job of keeping up to date on those things. And you might have noticed that from my demo is that I'm using Ionic for all of my web views and web code because it makes it really easy.
And there wouldn't be any way to kind of prevent the native side from updating that UI until the web portion is implemented, right? You just kind of have to go with it.
Correct. And I think that, with portals, we look a lot to the native team to be responsible for the overall application because they are.
Right.
Teams are just contributing. They're teams that add value, but really not the ownership of the overall experience. That's the native team.
They're more of like a consulted player coming in, adding their parts when they need to, and then the other teams are really doing majority of the work.
Yeah, they're feature-based teams is how we would look at it.
Cool. So I think I found the perfect questions for Christine.
Just before you move on to the next question, just a little plug. If you are interested in learning about design systems while creating micro front-end applications, check out week 3, January 18th at 11 a.m. We have a session on that. And I also don't know if you're about to ask this question, but I've seen a few questions about Module Federation. That's happening next week, January 11th at 10 a.m. So if you have a lot of questions about Module Federation, be sure to check out that session as well.
Perfect. Awesome. Yeah, I did not see the Module Federation, but the design systems session is something that I am very much excited about. So I think for the final question of the Q&A, would you say that micro front ends are the future of web development? This is an open question for both of you.
I wouldn't. I would say that this approach has been around for a long time, right? I had said that in my talk that people used frames back in the day in order to separate web applications. I think it's inherent to the web, something that has existed. I think that it's not the future. I think it's the present. And I think that it's an approach that organizations are probably already using. We're just putting a name to it.
We're just coming in here and adding our own little bits to make it.
I would say it's the future of native development, though.
Ooh.
I was just about to say, I think, Josh, you nailed that.
Hot take right there. Cool. Awesome. Well, thank you so much.